Hi guys, welcome to my channel Math for Teens. Today we're going to be learning how to do synthetic division. Now this is a way that we can divide polynomials if and only if our denominator or our divisor is of first degree. So its largest exponent, of a variable will be 1. So with that out of the way, let's proceed with the video. The first thing we're going to want to do is kind of make this half rectangle, and we're going to want to place the root of our divisor. So whatever value x has to be so that this becomes 0, here it's -6. We're going to want to place it outside of our half box. Now this also explains why down here has to be of first degree, because if it was of second degree, third degree, it could have many possible roots. So you wouldn't know which value to put here. So it's important that your denominator here is of first degree. It only has one root. So now that we have -6 over here, we want to place all the coefficients of our terms in this box. Only the coefficients. You don't need your x squares. And you also want to make sure that you go from the biggest to the smallest. So you would start with your 5 right here, and you want to make sure that you don't skip variables. So even if I didn't have an x, if even I didn't have a 6x, I would still have to put a 0 for my x1, even if there was no x1 in the equation. You can't be skipping terms. You couldn't just go from 3x squared to 21, because that would assume that 21 is the coefficient of x. So let's now write the coefficients down here. I have my 5, I have -3, I have 6, and I have 21. So your first step is, after this, is to bring down your 5. 5 is just a direct copy of itself. Bring down your your biggest coefficient. Bring it your first coefficient. Leading coefficient, dominant coefficient, or leading, I don't know. You bring it down. Next thing, multiply. 5 times -6, -30. Place -30 here, and you're always just going to be adding the term on top of it. So -30 plus -3, let's just go to -33. Again, you bring a term down here, you multiply by your root. So -33 times -6. So let's see, the minuses would become positive. Obviously, you'd have 180 plus 18, so 198. All right, so 198. So this term that we got by multiplying these two, we are again going to add the term on top with the term on the bottom. So this will just give us 204, my bad. 204 times -6. So let's see, 1,200 minus 1,224, I want to say. 1224. Let's just check that. I don't really want to redo this. That seems right. Okay. Plus 21. So minus 1,224 plus 21, that should make minus 1,203. What I want to say, minus 1,203. So now we don't have any other terms down here, coefficients to multiply by, so we're done. So at this point, this is almost our solution. We just need to add back the variables. So if this 5 used to be with an x cubed, now you'll have 5x squared, because remember, first I should probably note that this is your quotient, and your last term is your remainder. So if your last term was 0, it means you have a remainder of 0, which means this denominator would perfectly divide this numerator, or it would be a factor of your original polynomial. But here that's not the case. We have minus 1,203. So we know that x plus 6 is not a factor of all of this up here. So how are we going to write down our answer now? So well, let's first just say your denominator would multiply with your quotient, and then you would need to add your remainder to get to your original expression, right? So I'm going to call this divisor. Look, I go to French school. I don't know what you call it in English. So I'm sorry if it's not the real word. But so divisor times quotient plus remainder is equal to, why don't we just call this numerator f of x? Okay. So this should make some sense, right? Like, it's kind of basic laws of division. Okay, so if we want to write this out now, we would say our divisor, x plus 6. And remember, these are just the coefficients of your quotient. You obviously have to add your x squared, because if we want this first term to go back to x cubed, you would need to have x squared. You know, x times x cubed times x squared is x cubed. So you always lower the degree of their variables by 1. So 5x squared minus 33x plus 204. So we've just done this part, and then plus our remainder. So minus 1203 is equal to 5x cubed minus 3x squared plus 6x plus, okay. So this is one way to write out our answer, but technically the question was asking our f of x divided by x plus 6, and that's not the same form that we have in our answer. So usually you'll want to answer the question exactly as it was given, so we need to divide both sides. We need to divide both sides by x plus 6. So we will do 5x cubed minus 3x squared plus 6x plus 21, dividing both sides by x plus 6. We'll lose this, and we're going to divide this by x plus 6. Right, what we do on one side, we have to do on the other side. So will be equal to, so we already divided this term by x plus 6. And we also need to divide this term by x plus 6. So first, let's write out this term. Right, if it was used being, if before it was multiplied by x plus 6 and then we divided by x plus 6 divided by x plus 6 is just 1. So this will just go back to our quotient. Sorry, I don't know why I put a plus there. Minus 33x plus 204. And then this term we need to divide by x plus 6. So minus 1203 divided by x plus 6. So this will be our final answer. Well, this will be our answer. We will just want to make sure that we write out that x cannot be equal to minus 6. Because if you had x equals minus 6 in your denominator, it would become 0, and that's undefined. Thanks so much for watching my video. I hope it helped. And don't forget to come back for part 2, where we will explore synthetic division problems where the divisor has a leading coefficient other than 1.